This is where you have to get creative. Okay. So far, have we even studied delta of t for a second order differential equation? No, we haven't. And so far what was slick was, remember we spent a whole bunch of time figuring out how to integrate the delta function. And it worked really well when you had a first order linear differential equation, because we could multiply through by an integrating factor. We could integrate that, we could use that fundamental theorem of calculus, and the answers kind of just came together for us. But notice that our integrating factor technique doesn't work with this second order system. So the solution is in essentially recreating the idea using your initial conditions. So here's what we do. We solve the system by use of, okay, I have to go all the way back there here. What do I have? I can't see. Solve the system by use of initial conditions. Here we go. You didn't have to start a new page. You could just continue it. Initial conditions. Okay, so let's think about our initial conditions. Let's think about those. Okay, when the car was just sitting there, what was y of 0? It was just what? Sitting there. Yeah. It was just at rest. So in other words, there was no displacement on that bumper until I came along, or until you came along. So what we would say is the car was just being left alone. That's our initial condition. So yes. Yeah, set the bumper at the origin. Nothing's happened. It's at rest. So this is. I'm going to put this so you can think of it pictorially as this is the car at rest. Car at rest. Okay. So when I come along, though, I am going to jump on that thing as hard as I possibly can, and I'm going to provide it some initial velocity. So what happens, though, is at that moment of rest, we're going to introduce at time 0, when it was resting, you would think it wasn't resting, but now we're going to give it an initial velocity of some value. And, okay, I'm going to be honest here with you. The book uses 1 over capital A. And I haven't quite made my peace as to why you need the over A. Because I've checked the solutions a number of times, and they still work without the A. But I figure that the author knows something that I don't know. So we'll put the A in. I have to admit, I just cannot figure out why it's needed because the solutions work even without the A. All right. Not only that, we call this system, now, okay, so there's our initial conditions, and then what we want to do is this. Our general solution, so this is what we do know. We know our general null solution. Oh, no, that's not it. So now this will make more sense. Now we can solve a y double prime plus b y prime plus cy equals 0. It's this initial velocity now that we've introduced when it's at rest, that's how we account for the delta function. It is. All right, let's take a 10-minute break. We're going to get back. Yeah, just make it 10 since I was already on.